Hello, let's get started. It's nice to meet you here. My talk is about building bare metal platform with Talos Linux. My name is Andrei Kvapel, and what I do, I can tell a little bit about my experience. Actually, I started my Kubernetes experience working as cloud engineer at Vedos. It is the biggest Czech hosting company. We were doing a lot of interesting stuff like automating thousands of servers and of course running Kubernetes on top of those bare metal nodes. So I got a lot of experience with preparation of bare metal clusters. And this is not only about Kubernetes, you also have to solve things like storage, networking, isolation, and things like that. So lately I switched to working as solutions architect at Pelark. We were building a platform for Kubernetes, which includes all of this stuff. And since 2023, I started my own business. So I founded Ionix, and we built open source solution, Cozystack, for providing managed services for service providers. And my presentation can be split to three different parts. First, I will tell you a story about how I get to know about Talos Linux itself and how we organize processes for make it working. So the story starts from I was always had burning idea to build my own cloud. This cloud should provide you storage, networking, virtual machines, and Kubernetes as a service. Of course, it should have Kubernetes compatible API. And this is a story about that. I found a sponsor because I can sponsor it by myself. I found a sponsor and we get a deal. He told me, hey, I have an infrastructure that was Kubernetes infrastructure. Please help me to prepare my infrastructure and then I will sponsor your project. So we got this deal. But when I found how they preparing their Kubernetes clusters, I was really surprised because the regular pipeline for preparing Kubernetes cluster was really difficult. Every time when they get a new request for getting new cluster, they were creating virtual machine, then installing Linux on them, then use some Ansible scripts, actually kubespray for install Kubernetes, but that's not all. Every cluster also should be configured, so some certain system components should be installed on it. So those components were installed through the Helm. The configuration for every cluster was stored in GitLab. For every specific cluster was created specific Git repository with different set of values for different components. So we can see that this pipeline is very difficult, and with Talos Linux you can actually simplify it. Let's try to simplify it somehow. First, we can take this part and move to the virtual machine. If you use ready images, you don't have to install Linux on virtual machines. You can just use ready images with operating system. We can also get rid of this part if we will just use Talos Linux, because Talos Linux is Kubernetes specific distribution. It provides you Kubernetes out of the box. Actually, the main reason why Talos exists is to provide reliable Kubernetes. So in this way, you can just boot your virtual machines and Talos Linux will provide you Kubernetes. What about this part? This can also be simply simplified. Let's move it to one specific repository which will hold the configuration for every cluster, because it is not so different for across the clusters. And let's replace Helm with Fluxcd, which will just sync these configuration files into every installable cluster. And finally, we got this simple pipeline. When we got requests, we create virtual machines, we bootstrap Talos Linux on them, and then Fluxcd installs the configuration, which is unified for every cluster. Looks good, but how does it work? Let's say you have an infrastructure. It can be virtual machines. It can be virtual machines running in cloud or on-prem servers. It can be on-prem servers itself. Talos Linux has images for every platform you can imagine. So we usually used Proxmox images and OpenStack, but there are also options to have more generic configuration. You can install it using standard methods like ISO and PXE. And also, if you want to try out Talos Linux on your machine, you can just use Docker, and Talos has implementation to just simply run virtual clusters on your local machine. So, the initial bootstrap, you need to boot Talos Linux on every virtual machine. It can be done multiple different ways, but if you use virtual machines, you can just create virtual machine with basic Talos Linux image, and then you'll get, they will boot it and they will be available in maintenance mode. To configure your virtual machine, Talos Linux has single configuration file in YAML format. That's very cool that you can configure the whole machine just with single configuration file. Let's take a look what is inside. We can split it to two sections. Machine section, which describes settings for specific certain machine. And it also has cluster section, which describes the configuration for whole cluster. In machine section, you can specify what type of machine is it. Can it be control plane or worker? You also specify certificates for Talos and cert-sans. Because Talos Linux has its own API, it is not the same API which Kubernetes has. And also configuration for networks interfaces, IP addresses, and disk to install. Very simple. While cluster section includes the configuration for Kubernetes control plane, their own certificates for the cluster, for Kubernetes itself, and you can also specify settings for every specific cluster component, like API server, controller manager, etcd. So you can write single configuration file, and the only thing you need to do is to apply it to the virtual machine with talosctl tool, which is very similar to kubectl. So when you apply this configuration, your virtual machine gets configured, and you can almost immediately start using it. If we want to bootstrap the cluster, the usual procedure is the following. First, we generate secrets. We get a file which includes the secrets for cluster and for Kubernetes itself. So all the secrets in single file. Then we can use this file and use second command. talosctl gen config with secrets, and we will get 3 more files like talos config. It is used to access Talos API the same way like kubeconfig, but for Talos, and 2 configuration files for configuring control plane and worker nodes. The next step is to apply this generated configuration. You can modify it if you want to, but after that you have to apply it to the virtual machine. So you use talosctl apply, and you just apply this configuration file to the virtual machine, and they get configured. The single command should be written later, talosctl bootstrap, which will create one on the one of virtual machine. It will initiate etcd cluster. Then they will find each other, automatically, magically create Kubernetes cluster. Ta-da! You have a ready Kubernetes cluster. But that's not at all. How can you update the nodes? Actually, the way is similar. You just update your configuration, apply it again, and run upgrade. During the upgrade, the node itself will move all the workload from itself, remove itself from the cluster, not actually remove, but it will take care about your workload running on it. So it will not go down until all workload will be moved out of this. Then it will update the image itself, then join back to the cluster. So this way it works really well even on bare metal. Okay, how can you access this cluster after it gets created? We really use this feature, which called VIP. It creates floating IP address on all of these virtual machines, and you can use the same IP for accessing Kubernetes itself. So if you have kubeconfig generated out of this cluster section, it has the same IP address for accessing these virtual machines. And if you need, this floating IP will be automatically moved to the different nodes. If one node fail, it will be moved to another. So it's fault tolerant by default. Okay, but you can't simply use Kubernetes API because there are a lot of things under the ground which you need to make working before you start deploying your application. You need the storage, you need networking, and how can we configure it? Actually, I'm talking about such things like cert manager, configure role-based access control, CNI, monitoring, and stuff like that. As I told, we fully rely on Fluxity. Fluxity integrates with Talos ecosystem very easily. You can just configure Fluxity to take these components and deliver it to the cluster internally. If we'll look into Talos configuration, you can even specify it in extra manifest section. So the first link can be used for installing Fluxity itself, and the second link can be used for configuring the cluster itself. So finally, you can, with single config, you can bootstrap a cluster with all needed components. Finally, we get configuration, which is stored externally. When we get request, we create virtual machine, and it gets applied through the Fluxity. This works well. This works well with virtual machines, but when you use bare metal servers, there are a lot of challenges which you have to solve. And now let's switch to the next part of my presentation, because our platform is mainly prepared to be run on bare metal servers, and I will explain you what challenges we got and how we successfully solved it with Talos Linux. So every time when you bootstrap your bare metal servers, you have to worry about firmwares used and kernel modules used in your system. So if you use some storage, as it expects to be ZFS module and DRBD available, we just need to be sure that those modules in exact versions get installed with Talos Linux. The second question is how to boot actually Talos Linux on bare metal nodes, because usually you have, when you have virtual machines, you can just create virtual machine out of the image. You can't just create your bare metal server with prepared Talos Linux image. So you still have to solve this bootstrap procedure somehow. Then you also have to provide the way for choosing the correct disks and interfaces. And the next problem is that every bare metal server is different. They have different interfaces, different disks, and you need to provide some easy way to choosing them. So the first question was solved by preparing one common Talos Linux image, which includes all the needed firmwares and also the modules we use in our platform. So we bake this image and ship together with the platform. We can always be sure that it will be working, that it have exactly needed kernel version and kernel modules. If you want to bake your own Talos Linux image, you can use dev factory factory.talos.dev. But if you want to build it locally, you can do this using another YAML definition. You actually specify what official extensions you want to add at the build time and what kernel modules it should include. And you can also specify output format. And finally, you just run single Docker command, and you get the image, which can be used as ordinary Talos Linux image, but it will include all of these firmwares and kernel modules. Okay, we got image, but how can we boot it on our bare metal nodes? Of course, you can use more generic way to generate ISO image, but that will presume that you will need to add this image to bare metal server, connect to APMI, boot it, then put network settings. That looks really difficult if you have multiple nodes. We prefer PXE booting method. That means that you have to have in your infrastructure DCP and PXE server, which giving to the nodes the exact image which we prepared on the previous step. For example, if you have bare metal servers and you have these services running, you just turn them on, and they get booted to Talos Linux maintenance mode automatically. And then we also simplify this way by generating we actually just put these DHCP and Pixie servers into Docker containers and packed it together. So if you want to just run our platform, you will need to run just 2 Docker commands, and later all the nodes on your bare metal infrastructure will be booted automatically. So the next question is how to provide user a choice for the correct disks and network settings, because our customers using our platform and they are happy, but the configuration might be really difficult. And one of the biggest problem is to get to provide them easy way to try our platform. So for this, we implemented our own method, Talos installation method. It calls Talos Bootstrap. Actually, it is just simple shell script, which you can see it will invoke talosctl commands. The main idea here that you have some laptop or virtual machine connected to the same network as your servers. You run these 2 Docker containers, then your nodes get booted from it, and then you use this Talos Bootstrap to bootstrap and configure Kubernetes cluster in it. Let's see how it works. It looks like old school Debian installation method. So after your nodes get booted, you just start the script. It will find all the nodes in your environment and will allow you to bootstrap. So you just put your needed host name, choose the right disk, enter network settings, DNS names, Kubernetes endpoint. It will also configure a load balancer automatically. Finally, it will generate this simple YAML configuration file for Talos. And then it will track the installation. Ta-da! In 5 minutes, you can get a ready Talos cluster, even on bare metal, with simple. And also, it will boot the same image which we prepared. So it provides us stable base for running the REST components of our platform. I can say that we have few layers, and this is like basic layer which should be super stable before we start deploying anything on this. In this layer we have Linux, and we also have Kubernetes, and we have all the needed kernel modules, kernel version. So we are ready to bootstrap the other stuff. And let's talk about building a platform. I probably need to talk a little bit about our platform. So the main idea that we have this dashboard where you can click and install all the services you need. You can order Kubernetes cluster, or you can order Redis, Postgres, MySQL, or just ordinary virtual machine. The main value of our platform is to provide you opportunity to bootstrap it on bare metal servers. So as I told you, we have few layers. The first layer is Linux and Kubernetes. The next layer we provide by platform is storage, networking, and virtualization. For storage, we use LinStore. This thing very depends on kernel and kernel modules, but it provides you really fast replication. For networking, we use OVN. This is really modern networking fabric. It works very well with KubeVirt. And for virtualization, we use KubeVirt. The next layer is operators, cluster API, and monitoring. So this is also these building blocks we provide in our platform. And finally, we provide you an opportunity to order managed Kubernetes clusters, managed databases as a service from the dashboard. And the rest part, not even layer 2, layer 3, even layer 4, is managed through the Flux CD, but slightly different approach. And also, we implemented our own approach. So in our case, Flux CD syncs the data not from the Git, but from the existing Helm charts repository. Anyway, if you want to install the platform on the cluster you just created on Talos, You just have to apply a single YAML file into Kubernetes, and a new container will be created. This container will hold Helm charts repository and also a simple script which will install Fluxcd. And Fluxcd will install all the components from this container to the cluster. So anytime if you want to update this platform, you just create new container with newer version of platform, and Fluxcd just updates all the needed components in the same cluster. Okay, but as we know, Talos Linux have no bash, have no SSH. The good question is how to debug Talos Linux, and that's one of the popular question customers asking us, like how can we debug it and what actually we can do with this. Talos Linux itself has a lot of useful commands which you can run even through the API from your local machine, and you can do packet capture, you can see kernel logs, you can see memory utilization, but that's not always enough. Sometimes you want to debug even more. You need to get into the machine, you want to run TCP dump, or you want to connect to CRI to see what exactly happening there. For this way, you probably know this plugin. This plugin was written by me. It's called kubectl nutshell, and when I started using Talos Linux, I implemented -x mode. All what it do, it just creates simple container which have access to the system in maximum privileges. You can use this command to debug the node. You have access to the file system, but you still can't somehow to break it somehow. Because Talos Linux secure enough, it will not just allow you to break. There is an opportunity how can you break it, but still I think this is really needed feature for debugging nodes, and I use it every day. So finally we got a lot of environments which are unified and reproducible. We can even give support to our customers not having access to their infrastructure. Because we always sure that they use the same stacks, same kernels, same Kubernetes version, and it works exactly the same, so we can modulate the issues they have on our own environment and say where exactly the problem is. We provide simple interface for installation and for debugging. For now, we have even second method for bootstrapping nodes, but it still allows you to query the data, what the disks they have. It's Helm-based approach. It's called Talm. It's not mentioned in this presentation, but if you like Talos Bootstrap, the next step can be you can try Talm for configuring your Talos nodes. And our platform covers all the infrastructure stack, so we provide storage, networking. You don't need to buy additional nodes for like storage nodes. You just boot and install it, and it is immediately ready to use. And we are open source. Please give us star, fork it, and join our community. We have weekly meetings where everybody can join, participate into development. Here are links. Link to Talos Linux itself, to our platform Cozystack, and there are also 3 beautiful articles I wrote on Kubernetes.io blog, where explained how exactly the things working under the hood. You also might be interested. After tomorrow, I will have a presentation at 12:30. It's called Mastering Metal. It will be focused more on how things works on the next layers, not only Talos Linux. Thank you, everyone. Thank you, my wife, for making this beautiful presentation design. And now I'm ready to answer your questions. Any questions? Wow. I didn't expect that. I can give some ideas like how do you configure your network devices if bonding or VLAN support it. You can ask how we actually run Kubernetes in Kubernetes and why are we doing this. Okay, good question. Thank you, Andrei. We provide, actually, I think that Kubernetes is not multi-tenant solution. It is always intended to have separate Kubernetes cluster for every team of development, for every project. But if you use Kubernetes on bare metal, it is not easy to split it to different users. So in this way, we decided to split the platform to different responsibility zones. The responsibility zone of us, so we can control all these managed services and we know how it works, we can update it, and user-faced services, they can run only in their, so they actually run their code in virtual machines, provision it in the same Kubernetes cluster, provision it by KubeVirt. In this way, if customer needs to run their application, they can just get their new namespace, order Postgres, Kafka, Redis, and their own Kubernetes cluster. So they will get their own API where they can install their operators, custom resources, and communicate to these services directly. This is how it works. I think that's exactly a subject I will talk after tomorrow. It's a 3-day. Please join. I'll show you how it works. Yes, please.
Thank you. And do you also use Talos for the user cluster, Kubernetes cluster?
No, we don't use customer for user cluster for now. The reason for this, because we like to run control plane as pods, so we use Kamaji project, which provides you native way for bootstrapping Kubernetes. If you'll see how Kubernetes control plane works, it's like normal application which needs to store the data in etcd. You have API server and few microservices. So we just moved all the moving parts from the user cluster to the management, and we just give them APIs so they don't even see their control plane nodes. Currently, Talos Linux does not support this mode, so we decided to use the native Kubernetes approach. And our existing workers, just simple Ubuntu servers with kubelets. I think we can replace it with something even smaller. I know just kernel, kubelet, and kubeadm, nothing else.
Nice. I missed the name of the project. Can you tell me?
It's called Cozystack.
No, not yours.
Kamaji. This is solution from Classics.
Okay.
The same developer from Capsula project.
Yeah, nice. Thank you.
And we also build a community for building etcd operator. And right now we're working hard on moving these two projects, like our etcd operator and Cozystack, to CNCF. So we will looking for more contributors and more adopters. Come on and join our community. Please give us a star at GitHub. It will help.
On one of the first slides, you showed that you install a specific storage system as part of your stack. And I was wondering if that's actually a good idea to have a storage system baked into your solution, because if you have heavy workloads heavily dumping on the storage system, you could easily bottleneck your networking, right?
This is a good question. We use LinStore. LinStore is not exactly clustered storage. I would say it's more likely orchestrator for storage. First of all the databases you saw on dashboard, they don't use replication, storage-based replication at all. So LinStore is used to cutting off the volumes for them locally. And in this way, you have really native performance by running those databases on bare metal, on same volumes without storage-based replication. But for user data, we can't be sure that this data can be lost. We need to have replication, and in this way, LinStore allows you to create the same volumes, but they enable DRBD replications like RAID 1 on top of ordinary volumes. In this way, it will work also good because we have data locality. That means that your data, to write your I/O operations, you shouldn't go to two different servers or to one and wait until it will replicate to another one. It will just write one replica on the same node where virtual machine or service is running, and the second one hop by network, it will write to the second node. So in this way, if we compare LinStore with Ceph, for example, it does not consume a lot of resources and it works really well. Any other questions? Yes, please.
So you had that catalog of applications. I'm not sure if I just missed you saying.
Please put it more.
Oh, if I've got to be a bit closer. So you had that catalog of applications that you're then providing. How is that extended?
All the applications you see here, actually, this dashboard is based on project which is called CubeApps, and it is it is backed by FluxCD. In FluxCD, you have specific entities like Helm repository, Helm release, Helm chart in Kubernetes. So if you want to extend this dashboard, you can just specify additional Helm release. No, Helm repository, and it will be shown here. You should understand that those applications you're seeing here, they're not managed by Helm. So Helm does not provide lifecycle management. The platform is still based on operator-based approach, and Helm charts are needed just to combine all the components needed to start Postgres, to configure monitoring, actually to put a set of YAMLs into cluster. So it allows you to make the configuration easier with single YAML which you define. So you can prepare your own Helm chart, which will include just few YAMLs for your operator, and connect it to the platform, and it will show the application here.
Thank you.
More a question about Cozystack. You give the customer the ability to pick their applications with this dashboard. But how is your customer built? Is that how many resources they can use, or where is that measured or decided?
Yeah, for now we are working on this. We always position Cozystack as backend for building cloud. That means that we don't provide full functionality like end user interface. This interface you think here, it's more likely interface for administrator. We follow API-driven approach. And the question is how to limit customers to have a specific set of resources. You can usually use just normal resource quotas. I think in one of the following release, we will put tenant configuration for every tenant. So when you create tenant, you can specify all the how many resources it can consume. And the other part, sometimes our clients asking if they can provide billing information. So for now, we decided to base our solution on to provide billing information based on open cost. You can query how much resources user used for specific amount of time. So the answer is resource quotas, but it is not implemented yet. I think it will be implemented in few releases later.
Thank you for presentation. You said that you use GitOps approach. And what is happening when I click, for example, to have monitoring gateway or MySQL instance? Will it deploy special as I understand, it will deploy a special YAML manifest to management Kubernetes cluster. But will it commit this manifest to special repository, or how does it work?
This will not commit. This dashboard is really useful thing if you want to understand how the platform works. But we not suggest it using on everyday base. So we have a reference repository where you can see how can you define all the needed components needed to run your infrastructure and use just connect it to Flux, and it will sync it from Git repository to the cluster. So the approach is different. You can, when you start using platform, you can use dashboard and then try installing it manually, but then you can get your generated configuration and put into Git. And then you can use Git for delivering your applications in the environments into the platform itself. Other questions? We have to give presents for the best question. Sorry, but for now I have no any presents. I can give you some stickers if you want to. In this way, I think we can say thank you. Thank you for attending. Please take a look at my next presentation. I think it will explain you a little bit more if you're interested. That's it. Thank you.